1 Newton. I just used the value of T there. So we solved for T, we solved for H. We now need to solve for V. That means take the value of T to your second equation. Let's do that over here. This is the second equation. V plus 0.5T equal to 129. Now in this equation we replace this T by its value we calculated, which is 209 Newton. So that will be V equal to 129 minus 0.5T. That will be 129 minus 0.5 times 209. That is 24.5 Newton. Well, we've got V equal to 24.5 Newton and H equal to 181 Newton. Look at the way I've drawn these vectors now. I drew my H vector and I drew my V vector from the head of H. You see, as long as you have the same direction and the same length, a vector can be drawn anywhere. So we have H and V. Can you find the force at the hinges? Well, if F is the force at A, at the hinges, then the magnitude of that F will be the length of this vector will be square root of H squared plus V squared. Well, H is 181, V is 24.5, and that gives you square root of 181 squared plus 24.5 squared is 182.7 Newton is the force at the point A, the magnitude of the force. Well, we also need to find that angle. How do you find the angle? Tan theta equal to, or theta equal to tan inverse of y over x. That's right. So if theta is the angle F makes with the strut, that is this angle, then tan theta equal to V divided by H. That is 24.5 divided by 181. That is 0.135. Therefore, theta equal to tan inverse of 0.135. That is 7.7 degrees. So we now obtained all the forces acting on the strut. The tension T is 209 Newton. The force acting at the hinges is F equal to 182.7 Newton at an angle 7.7 degrees. Isn't that a beautiful problem? I'm sure you enjoyed it. So please try and do this couple of problems like this on your own. I have given you a couple of problems like this in the homework. Okay. There you are. Let's do another problem. A uniform meter stick weighing 5 Newton is pivoted so that it can rotate about a horizontal axis through one end. Well, a meter rule is pivoted like this, means it can rotate about a horizontal axis. Look at this. This is the axis, that is horizontal. And the rotation, you can rotate about that horizontal axis. It is pivoted here so that it can rotate about that horizontal axis. If a 0.15 kilogram mass is suspended 75 centimeter from the pivoted end, what force must be applied at the free end of the meter stick to maintain it in a horizontal position or to maintain it in equilibrium? Can you picture that? It's very important to make a picture in your mind. A meter rule is pivoted at its 0 point at one end. Now, what is done here? the meter stick is pivoted at A. Its weight is acting vertically down. Now, you got to read the question very carefully. Sometimes I give you the mass of the ruler. Then you got to figure out the weight as mg. But here I give you the weight. It is 5 Newton. So the weight of the ruler is 5 Newton. It is acting vertically down at the 0.5 meter mark. This is the 0.5 meter mark. So that means that distance is 0.5 meter. The weight of 0.15 kilogram, we have a 0.15 kilogram mass suspended at the 75 centimeter mark. Now what is the mass of this 0.15 kilogram? It will be 0.15 kilogram times 9.8 meter per second squared. That is 1.47 Newton acting vertically down. And what is this mark? This is the 75 meter mark, 0.75 meter mark. So this distance is 0.75 meter. Okay, we are looking for the upward force. You can see this is the pivot point. That means the weight of the ruler is rotating it clockwise. This 1.47 Newton also is rotating it clockwise. In order to balance it, you need a counterclockwise torque. And that is going to be provided by a force that is applied at the free end. We need to find that force. What force must be applied at the free end so as to maintain the horizontal position? We need to figure out what the magnitude of that force is. Well, okay, the distance of this force from the pivot point is, what is that distance? It is the length of the meter rule, which is 1 meter. Alright, what all we need to do is find the torques of all these forces above the pivot point. So, let's find the torque of 5 Newton about an axis that passes through A. You can see the horizontal axis there. Now, what is the torque of this 5 Newton about A? It will be this torque arm times 5 Newton. 0.5 meter times 5 Newton, which is a clockwise torque and therefore negative. And that is negative 2.5 meter Newton is the torque of this 5 Newton about A. Similarly, what is the torque of 1.47 Newton about an axis through A? It will be, the torque arm is 0.75 multiplied by the force is 1.47, and that is a clockwise torque. You see, a clockwise torque, therefore that is negative 0.75 meter times 1.47. That is negative 1.1 meter Newton. Alright, what is the torque of the force F about the point A? The torque of F Newton about A, the torque arm is 1 meter multiplied by F, 1 meter multiplied by F, and that is a counterclockwise torque. That is equal to F times 1 is F, that will be F meter Newton counterclockwise, and therefore it is positive. And to solve the problem, what all you need to do is add all the torques and set it equal to 0. Summation of tau gives negative 2.5 meter Newton minus 1.1 meter Newton plus F equal to 0. Negative 2.5 minus 1.1 plus F equal to 0. You can see, you can find F from there straight away. F equal to 3.6 Newton, and that is the force that you needed to balance that meter rule. Well, I think we did a few very good problems, and I want you to review them. Do them a couple of times on your own and practice so that you can do problems like this. Alright, I think we have now come to the end of Unit 4 of the course, and you should be now ready to take your Unit 4 test. Alright, again let me tell you, do the practice test first, and then make sure that you can actually do all the questions. And please take the test before the expiry date. Alright, I will get back to you with Unit 5 later.